For this example, we have 4 less than or equal to 5x minus 6 less than or equal to 19. And we call this situation a nested inequality. Nested inequality. What this notation means is that we really have 2 inequalities for the price of 1 here. 4 less than or equal to 5x minus 6 is 1, and then 5x minus 6 less than or equal to 19 is the other. But hey, we get 2 for the price of 1 by kind of sandwiching everything together like that. Let's learn how to solve these. It's very fast. It's really neat. You do the same thing you would just in normal solving, but now you do these operations to 3 sides at the same time. I'll show you what I mean. We're trying to work our way in towards x here, right? That's our goal. So let's do it. So I need to get rid of this minus 6 here, so I'm going to add 6. And I do it to all 3 sides at the same time. Look at that. So now we have 10 less than or equal to 5x less than or equal to 25. Okay, and now we still want to get x by itself, so I'm going to divide both, or I guess all 3 sides in this case, by 5. Right, so that gives us 2 less than or equal to x less than or equal to 5. Okay, and so that's our solution, though we want to either represent these in graph notation or interval notation. So let's do our graph notation. Here's our graph notation. We're just representing this interval right here, all this stuff. What this is saying is this is all of the stuff, all the numbers between 2 and 5. Okay, so there's our graph. I'll start with my 0 down here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's saying x is bigger than 2, but smaller than 5. All right, so here's how we do that. Let's just start at 2 here. We're including it because we have this equal sign here. The equal sign tells us to include the point in our interval, so that's why I'm using the hard bracket versus the soft bracket, which would be a parentheses. We start at 2, we stop at 5, and I'm filling in the stuff in the middle. So we kind of shade it like that, like so. All right, there's our graph notation. Interval notation is simply a representation of the graph notation. So it's the same idea. We start at 2, I'm doing a hard bracket because we include the point, and then we stop at 5. There we go. That there is our interval notation. Certainly less clunky than the graph notation, which is why we usually use interval notation over graph notation. Let's try another one. Here we have -5 less than or equal to 2 times the quantity x plus 4 less than 8. And you have a few options on how to proceed here. You could divide both sides by 2 right off the bat. I think I'm going to leave 2 in and instead distribute the 2 first. Both would work. There's slightly less fractions the way I'm about to do it though. So let's do that. So let's distribute the 2. So -5 less than or equal to 2x plus 8 less than 8. Alright. Subtract an 8 from all 3 sides at once. Alright. That gives us -13 down here less than or equal to 2x less than, oh interesting, less than 0. Okay. Then we divide both sides by 2. Also, we divide all 3 sides by 2 to get -13 halves less than or equal to x less than 0. Right, and it's very nicely nested. X is nested between these 2 values. We need to know what 13 halves is. It's equivalent to 6.5. So we can think of this as -6.5 less than or equal to x less than 0. Okay, that's just to help us know where to put it on the number line for our graph notation. So here's the graph. Okay, so we're going to be stuck between negative 6.5 and 0. So I'm going to put my 0 up here. 1, 2, 3, 4, 5, 6, 7. So 6.5 is right, negative 6.5 is right about here. All right, now this one, this 6.5 has the equal sign here, so that's going to get a closed bracket. All right, a closed bracket here at negative 6.5. Let's label that point negative 6.5, or we could also call this negative 13 halves right here. Okay, and then we're going to go up, up, up until we hit 0, and then we stop. But actually, this doesn't have the equal sign on it, so on the 0. So we are not going to quite hit the 0. We're going to stop just short of it. There we go. And then we stop just short of 0. Let's do the interval notation. Here's the interval. It's just a quick way of representing the graph notation. So we have a hard bracket here, negative 13 halves, and we go up to 0 with the soft bracket.